This is my 6.3 numerical model. So kinetics is the branch of mechanics that deals with the actions of forces. A force is a push or pull upon an object resulting from the object's interaction with another object. So there are two bits. There's linear, which has rectilinear and curvilinear, which is force, gravity, mass and weight, and angular, which is like movements and levers. And then you've got kinematics, and kinematics is a branch of the mechanics that deals with the motion or movement, and it is measured using mass times acceleration. So you've got linear, which is like straight line, curvilinear, which is curve, angular, around an axis, and general, which is linear and angular motion together. So how are numerical models created? They can be created by literature-based knowledge, which can be through books, computer or newspapers in order to get the data that is needed. Another way that numerical models are created is by watching an elite athlete and then comparing your chosen athlete in order to get your results, or you could use a specific athlete, which means you only look and focus on them. Alternatively, you can use a combination of different things to get the best results possible. So the advantages and disadvantages are the advantages, it's applicable to elite athlete and it improves your performance, identifies changes that need to be made, and it models successful people, reduce injury, and also can show how you can change the equipment to make them better. Disadvantage, however, is that it's complex. You need a deep theoretical knowledge. You also need to have good mathematical knowledge as well, and you need specialist equipment in a controlled environment, which can be expensive and is also time consuming to do. Scalars and vectors. Scalars is a value that has a magnitude and is how big, fast or far something is, so speed, and this can be distance, speed, mass or inertia. Vectors show the magnitude and direction, and so how fast up or down, and this velocity. So this can be displacement, velocity, acceleration, deceleration, weight or momentum. Speed and velocity. So the mean speed is how quickly a body moves, and it's measured in meters per second, and it is you can find it using the total distance divided by the total time. The mean velocity is how quickly a body has moved in a resultant direction and is measured in meters per speed, but you have to add the direction with it, and this is measured by total displacement divided by the total time. And so this is how to work out speed, distance and time, and you can use a formula triangle and switch that around to make it easier. And you do this by, so if you wanted to find time, you would cover up the t and then you would get distance over speed, and so if you wanted to get distance, you cover up the distance and you'll get speed times by time. So distance and displacement. Distance is the sum of all movements regardless of direction, and displacement is the straight line distance from point A to B in a particular direction. So if a body starts and finishes at the same place, the displacement is always zero, even though the round trip distance could be greater. For example, a shuttle run. This shows that if you change direction and finish at the same place you started, then the displacement and distance will not be the same. As a vector, displacement has a magnitude and direction. If a direction is positive, then it will have a plus sign or nothing, and if it is negative, then it will have a minus sign next to it. The plus or minus sign on the vector only indicates directions. Distance is a scalar that tells us how much the body has moved. Because it is a scalar, it has a magnitude but not a direction. Acceleration. So acceleration is the rate at which velocity changes and can represent a change in magnitude or velocity, the direction of velocity, vector or both. A negative acceleration could indicate that a body is speeding up or slowing down. Whenever the velocity starts and ends at zero, the average acceleration must be zero as well. And the larger sample of data, the less information about acceleration there is. Acceleration will be zero when the velocity is zero, the velocity is changing from positive to negative, or the velocity is not changing. Acceleration is the ratio between the ratio of the change in velocity to the change in time. And as you can see on the screen, that the acceleration equals the change in velocity over the change in time. When the change in acceleration is 0, the average acceleration must be 0. However, it doesn't mean that the acceleration is constant. The area under an acceleration time curve represents a change in velocity. If a change in velocity is 0, then the areas under the positive and negative acceleration curves must be the same. So there's some graphs. On the left shows an acceleration time graph, which for a basketball game, when the ball goes from one end of the court to the other, the player will have to accelerate fast at the start, and then near the end they slow down. And on the right shows velocity time graph, which shows a similar thing. Inertia. Inertia is the reluctance of a body to change its state in motion. And this is Newton's first law. And for example, if a basketball was still on the ground, it wouldn't move unless it is acted on by an internal force, like someone going along and pushing it or picking it up. There are 4 types of force. You've got internal, which is like the contractions of your muscles, vertical, which can be weight, air resistance, or normal reactions such as your buoyancy in water. Horizontal, which is friction, which is thrust in water, or air resistance, which is called drag in water. And external, which is air resistance, gravity, or friction. The effects of force on objects. You've got rest motion, change direction, acceleration, deceleration, and then change shape. There are 3 types of motions. You've got linear motion, which rectilinear is motion along a straight line, curvilinear is along a curved line, and then you've got angular motion, which moves in a circular path around an axis, and all the parts move through the same angle. And then you've got general motion, which is a combination of linear and angular. Newton's laws of motion. So the first law is inertia, which is the reluctance to change. Everybody at rest or moving with constant velocity in a straight line will continue in the state unless acted upon by an external force exerted upon it. So for a resting object, that would be a golf ball, and it won't move off the tee unless it is hit, and a moving one would be running. There can be a balanced force in motion, something that has a 0 net force, and no unbalanced external form equals no change in motion. Newton's second law is acceleration. The acceleration of a body is proportional to the force causing it, and the acceleration takes place in the direction in which the force acts. Acceleration is proportional to the size of the force, and the angle of the force also determines its acceleration. Size and direction of a force also determines the acceleration, and a net force can either produce acceleration or deceleration. If there is an equal vertical force, then they cancel each other out. So if 2 things going towards each other at the same speed with the same force, then it will cancel each other out, and nothing will go off the other way. The greater the mass, the less acceleration if the same force is applied. And the third Newton's law is action to reaction. So to every reaction there is an equal and opposite. No, to every action there is an equal and opposite reaction. For example, a sprinter, when they push off a block at the start, an equal force will push back at them, meaning that they're able to move. Direct and eccentric force. So eccentric force is a force whose line of application passes outside the centre of mass of the body, causing the resulting motion to be angular. And a direct force is a force whose line of application passes through the centre of mass of a body, causing the resulting motion to be linear. Impulse. So impulse is a force applied to an object for a certain amount of time. The greater the force, the greater the impulse. And for an impulse graph, the impulse area is the area under the grass. So you've got makes contact, and then as the contact gets bigger, it hits the point of maximum compression, and then it gets smaller again, and then that bit, the duration, is the impulse. So you can find the impulse by approximately putting it into a rectangle, and then its average height times by the average time. And impulse, as just said, equals a change in motion, change in momentum, and momentum is found out by mass times velocity. So for big force and big time will equal like a high vertical jump because of the force in the muscles. So if you have big force, then you'll be able to bend down, lift right up, and there's bigger time in the air, so then you would have a high vertical jump. Momentum. Momentum is the quantity of motion possessed by a body. Momentum equals mass times acceleration, and the greater the mass or velocity, the greater the momentum. So, for example, if a basketball player with a mass of 85 kg is travelling at 7.9 meters per second, would have a momentum of 671.5 kilograms per meters per second. Stability. Stability relates to how difficult it is to disturb a body from its balanced position, and it's determined by a number of principles. So the position of the athlete's centre of mass, the position of the athlete's line of gravity, and the size of the athlete's area of support. So for a basketball box out, you would need to have very good stability because you would have the person at the back pushing towards you in order to try and get the ball. So to stop you from falling over, you'd have to have your legs wide open. And so your the size of it would matter. To increase stability, the athlete would widen their base of support, as it would then give them a larger surface area so that they would be able to take more force before getting knocked over. However, for sports such as diving, they want to make themselves less stable before jumping so that they're able to just go up slightly but also forward slightly to be able to execute their dive safely without injuring themselves. They would also want to move their centre of mass so that they are able to do the somersault or something for the dive. So the centre of mass is the point at which the body is balanced in all directions. The base of support refers to the area beneath an object or person that includes every point of contact that the object or person makes with the supporting surface. And the line of gravity is a line extending from the centre of mass vertically down towards the ground.